Hey everyone, this is MusicTechHelpGuy, and welcome to part 7 of my Logic Pro 10 201 course. In this video, I want to talk about synthesis modulation. Modulation is essentially anything you can do to change the raw oscillator sound to make it more interesting and more complex. So this includes simple things like vibrato, filter sweeps, or even just making the volume fade in and fade out. But it also includes more complex things like frequency modulation and ring modulation. And this can be done at the oscillator level. This can be done in the filters. This can be done with effects. This can be done with the modulation routers here. It can be done with the vector envelope as well. So that's what we're going to cover in this video. And once again, I'll be using the ES2 to demonstrate this. So from the previous video, I have this sort of distorted monophonic legato unison heavily detuned synth lead. Let's set this to polyphonic, and I'm going to turn the distortion off because I want to create something that's more like a synth pad right now. Now it's got more of like an organ type quality to it. And first, let's talk about some modulation techniques going on in the oscillators themselves that we don't even have to use the modulation routers for. So just for demonstration, I'm going to turn off the filter and I'm going to turn the sine level down. And let's just go ahead and reset the tuning on all three oscillators as well. And I'll turn the analog option down as well. So let's start with just these first two oscillators. So you'll notice that there was a sine wave option down here. By the way, you can right click on this and you can choose one of 99 different waveforms to pick from, each with different tone characters. So again, you can right click on that or control click on this to pull up that menu. But there's also another sine wave up here, and you'll notice that there's a slider that goes up to this FM option. So what does FM mean? FM stands for frequency modulation synthesis. Basically what this means is that you have two or more oscillators whose frequencies can affect each other, meaning that the frequency of one oscillator is modulating into another, causing a more complex tone to be generated. So normally if I just had a sine wave pulled up here and a second sine wave pulled up here, and I played around with the tuning of oscillator 2, all you'd hear is harmony. You'd hear two notes or two oscillators playing at the same time. So right now we're harmonizing at 7 semitones, or a perfect fifth. But if I set oscillator 1 up to this FM option, now this becomes the frequency modulation depth. And what's happening is the frequency of oscillator 2 is being routed into oscillator number 1 and affecting its signal. So we're not going to hear that harmony anymore, but a tonal or timbral change. And you'll notice that certain intervals will sound better than others. It's not harmony anymore, it's frequency modulation. That's just a really basic example. You don't have to use a sine wave here for frequency modulation synthesis. You can use anything you want. So let's use something more complex like a sawtooth. So this can help to create some really sort of fat tones, whereas using standard additive synthesis, you couldn't really get that same tone. So in frequency modulation synthesis, the carrier wave is the wave that's actually being routed to the output, and then the waves that are actually being routed into the carrier are called the modulator waves, or the modulating waves. So in this case, oscillator 1 is the carrier wave, and 2 and 3 are both modulating waves. There's also an FM knob in the filter on filter 2. So let's set the blend all the way to 100% filter 2, And remember that filter 2 is a dedicated low-pass filter. So let's just pull the cutoff frequency around and let's find a sound that we like. That'll work. Let's put this back on legato, though. Let's really accentuate the analog knob a bit. There we go, a nice rich chorus effect. The FM knob controls the amount of frequency modulation happening between the oscillators and the frequency of the cutoff frequency in the filter. So essentially think of the oscillators here as a modulating wave, and think of the cutoff frequency of filter 2 as the carrier wave now. So this can introduce some pretty cool distortion and beating effects. And we can blend this with filter 1. So we can really get some nice fat bass sounds out of this. Now you can also save your presets as well. So let's say I want to save this distorted bass preset for later. What I can do is come up here to the preset menu and then save as, and then give it a name. So I'll just call this deep chorus bass. And then I can recall this preset at any time. Let's talk about a couple more different types of oscillator modulation, and then we'll move on to using the modulation routers. So you'll notice that on oscillator 1, there's a standard square wave right here. This is often called a 50-50 square wave because there's 50% up pulse, 50% down pulse. But there's also this square wave that has a thinner up pulse. This is an example of what's called pulse width modulation, and it's actually pretty simple. When you use a up pulse that's thinner, the composite voltage is lower than if you used a 50-50 wave where there's more up pulse, or the same amount of up pulse as down pulse. So essentially what you get is a thinner sort of metallic tone. So here's the regular square wave. And then here's your pulse width modulated thinner up pulse. Now, oscillators 2 and 3 take this one step further because you can modulate the amount of that pulse width modulation. So you can modulate how thin you want the up pulse. So you can vary this between a 50-50 square wave and a modulated pulse wave. So that's available on both oscillators 2 and 3. Oscillators 2 and 3 also have this option for sawtooth or square wave sync. Sync modulation is when you have the cycle or frequency of one oscillator sync up with another. So essentially what happens here is oscillator 1 serves as a master waveform, and the frequency of number 2 and 3, when they're on one of the two sync options, its cycle, its waveform, its wavelength will match up with or restart at the same frequency as number 1. So normally with just two sawtooth waves, if you started messing around with the tuning of the second oscillator, you just get harmony. But if you use a synced option, you don't get harmony anymore, you get a tonal shift. And you can do this with both 2 and 3. But notice if you down tune the oscillator, you don't really get much of an effect at all. The volume just gets lower. So that's oscillator sync, and this can be done with square wave as well as the sawtooth wave. Next, let's talk about ring modulation. Notice that when I turn oscillator 2 on by itself, with ring modulation applied, nothing happens. This is because ring modulation has to do with the adding and subtracting of frequencies. So if I pull in a sine wave here on oscillator 1, what happens is the frequency of the ring modulator and the frequency of the sine wave up here are added, then subtracted. So you get two additional overtones. So let's say hypothetically that the ring modulator's frequency is 500 hertz, and let's say that the sine wave is 1000 hertz. If you add those together, you get an overtone of 1500 hertz, and you also get an additional 500 hertz overtone, even though the ring modulator is already at 500 hertz. So you get 4 total tones. Now that's something really simple and that's assuming that the ring modulator and the sine wave are an octave apart. But if you start playing around with the frequency here, you get some different effects. So you can very clearly hear the sine wave, but you're also hearing the overtones produced by the ring modulator. And it's pretty similar to frequency modulation synthesis. It's a little different, but the sound is similar. Again, that's assuming that we're using just sine waves. If I put this on something more complex, like a sawtooth wave, we're going to get a more complex tone out of it because all of the frequencies are going to be modulated. So that's ring modulation synthesis. And the last thing I want to point out is on oscillator 3. Oscillator 3 has a dedicated noise generator. All this does is it produces white noise. No matter how you tune it, no matter what notes you play, you get noise. Noise can be used in modulation to give a bit of front-end punch to notes, almost like the front-end punch of like a snare drum. Noise can be used to provide like front-end attack using an envelope, but we'll get into that later. Okay, so let's talk about using the modulation routers. So you want to make sure that router is selected here, not vector mode. So go to router. And what modulation routers do is they allow you to affect certain modulation targets with various modulation sources. Now, most of the targets are up here, most of the sources are down here, and you can route these from this middle section of routers here. Now, just because there are 10 routers doesn't mean that you necessarily have to use all 10. You can actually get some pretty complex sounds just from using a few of them. So let me go ahead and reload my preset from before. And what I'm going to do is I'm going to load up this first modulation router here. So on the top here, you can choose a modulation target. So the target is actually what is being affected. So you can affect the pitch of the oscillators, the detuning of the oscillators, the cutoff frequency of the filters, or both cutoff frequencies of both filters, the resonance of the filters. So almost everything up here can be modulated. I'm going to show you a few basic examples. And the first one is vibrato. So I'm going to use pitch 1, 2, 3. And what that does is it modulates the pitch of all 3 oscillators. Now, right now, I don't want to use this via option. So I'm going to click on this and set this to off. And then I'm going to set a source. Now, typically, if you want your modulation effect to repeat itself, for it to be cyclic, you want to use an LFO. LFO stands for low frequency oscillator. Think of this as a really, really low frequency oscillator that you don't actually hear as an audible tone, but you hear the effect that it has on other sources or other oscillators. So in this case, imagine the pitch of the sound wiggling up and down in a vibrato effect. And the amount of that modulation is controlled by this slider here. So you can choose one of 2 LFOs. LFO 1 is right here, and LFO 2 is right here. The difference between the two is that LFO 1 can only be synchronized to a rate at hertz. So if this is on like 3.8 hertz, this means that the cyclical motion will move 3.8 times per second. With LFO 2, you can synchronize this to hertz, but also to musical timings. So if I want this to be like a half note or maybe a quarter note, you can do that here as well. So for now, I'm going to use LFO 1 for this. And there's different waveforms that you can choose. The waveforms for these, they don't have an effect on the like the tone of it, but they have an effect on the motion of the effect. So something like a vibrato effect, you're typically going to use a triangle wave for here. So this is going to make that pitch motion move up and down in the shape of a triangle wave. And let's make that go a little faster. Let's make that like 5 hertz. Maybe a little faster. Let's do 6. So let's say that we wanted that vibrato effect to be controlled by our modulation wheel on our MIDI controller. Well, what you can do is on this via parameter here, you can click on this and go down to mod wheel. Now what this does is it sets a range for the modulation. So if you click on this little middle button and then pull the orange triangle up, the orange triangle signifies the modulation effect at the top of the modulation wheel, and the green triangle is at the bottom of the modulation wheel. So essentially, our modulation wheel is going to control how much of this vibrato effect that we get. So with the mod wheel down, we get no vibrato. And with the mod wheel up, we get vibrato. So that gives us a secondary control source to control the modulation. Let's try another one. Instead of modulating the pitch, let's modulate the cutoff frequency of filter 2. And let's still use the mod wheel as our control source here. But let's use LFO 2, and let's make this move at a real slow rate, like a half note. And let's see what that sounds like. So imagine this cutoff frequency moving back and forth at the rate of a half note. So that's just a really basic filter sweep, but you can also pair this up with other filter elements like the resonance, for example, and you can also change up the bidirectionality of the depth of the modulation, so you can get a more complex sounding filter sweep. Right now, this is on LFO 1 moving really, really slow. And if you add a little reverb and delay to this, it can give it a bit more ambience as well. Another thing I like to do is I like to modulate the amplitude or amplifier, which essentially modulates the volume. So here I'm using LFO 2, and right now I have LFO 2 set to an 8th note, and instead of using the triangle wave, I'm actually using the bidirectional square wave, which is going to serve as a hard sort of on-off motion. So we're getting sort of like a rhythmic motive, but also that cool sweeping sound. So you can also use envelopes as a source instead of an LFO. So the difference between using an envelope as a source is that the motion only happens once. It doesn't repeat itself like an LFO does. Let's go ahead and bypass both of these routers, and I'm going to demonstrate envelope 3 real quick because envelope 3 is hardwired to volume. No matter what you do here with the routers, it always controls volume. So envelopes are typically made up of 4 or more stages, and the 4 main stages are attack, decay, sustain, and release. The 3 of these have to do with time. Attack, decay, and release have to do with time, but sustain has to do with amount. So if I use the volume envelope here and I pull the attack time up, this is going to make the whole volume sort of fade in. If I pull this down, the sound will immediately enter when I press the key. So for things like pads and strings, you can give this a little bit of front-end buffer by pulling up that attack. The attack stages in the ES2 also have this velocity-sensitive split fader. So if you split this, if I press the key softly, the sound will fade in more slowly. If I press them really hard, the sound immediately enters. Now, on the back end, the release time controls how long the sound lasts for when you release the keys. So when I release the keys now, the sound immediately fades to nothing. So it drops down to nothing. But if I pull up the release time, when I release the keys, the sound lingers for a while. So that's what the release time does. Now, in addition to that, you can set a sustain amount. This is the value where the signal will rest after the attack time and after the decay time. I'm skipping decay, but I'll come back to it in just a moment. So if I pull up the attack time and pull the sustain like halfway down, let's see what happens. That's the sustained resting amount. So notice that the sound peaked at a point and then came back down. That ramp back down is the decay time. This is how long it takes for the signal to ramp down to the sustain. If I want this more gradual, I can pull the decay time up. And if I want it more rapid, I can pull it down. So you can use the ADSR faders to shape the modulation of the volume here. But envelopes don't just have to control volume, they can control other things too. So if I turn on my cutoff and resonance targets here and change these from LFO to envelope number 2, now envelope number 2 is controlling these two modulation targets. So instead of these being repeating modulation patterns, this is going to be something that happens just once. So that filter sweep only happens once. And then if I pair that with my amplitude modulation on LFO 2, and you can also adjust the waveform for this as well. Like if I want this to be less of an on and off sort of modulation, I can try the sawtooth instead of the square wave. And what this does is it frees up our first LFO for some other modulation effect. So maybe I want to modulate the detuning of all of my oscillators a bit. For a bit of a chorus effect. Or maybe I want to modulate the pan of the entire synthesizer. I'm going to modulate the cutoff frequency of the first filter, and let's see what that sounds like. And I'm actually going to use this as a bass to reinforce the chorus of the song. So I'm actually going to go ahead and put this back in legato mode. I'm still going to keep unison on, but I may have to pull the volume down because it's probably going to be pretty loud. So with just a few minor tweaks and some piano roll editing, I've got a cool 8th note bass line to reinforce my chorus. Please tell me how, when all the world is lost, we're losing ground. If I wanted something harder, I could maybe switch this back to the square wave and then maybe pull up the distortion a bit. So another way to create motion is to use the vector envelope modulation here. So what I'm going to do is I'm actually going to turn off my amplitude modulation. So I just have this now. Just have my cutoff and resonance modulation along with a bunch of distortion. I'm going to go back to vector. Now the vector envelope controls two things. It controls these two pads here. This is called the mix pad and this is called the XY pad. And there's 4 modes. There's off, mix, which means that it controls this pad, XY, which just controls this pad, and then mix and XY, meaning that it controls both pads. I'm going to choose that mode. And what you can also do is you can set an X and a Y target, because this XY pad means nothing if you haven't assigned anything to the X and Y axes. So let's assign cut off number 1 to the X axis, and let's assign cutoff number 2 to the Y axis. And then you can pull up or down your intensity. So I'll pull this up a bit. And now when I play a note and I move the XY pad around, watch what happens. Now there's a lot of distortion in there, so let's pull the distortion out just for a moment. Let's actually make one of these targets have a negative intensity. Let's see what this does here. So there's some different tones in there. And what you can do with these two targets, in addition to just being able to move this around, is you can effectively automate the point of both of these pads using the vector envelope. Now, the vector envelope is really complex. I could do a whole hour-long video on just this, but I'm going to show you the way I like to use it. If you right-click here and choose Initialize to 8/8 loop, what this does is it creates 8 points where you can set the position of these two pads. So if I start here on 1 just as is, that's fine. Click on 2, move this one, go to 3, and you can just continue this over and over, just modulating these two pads. And what's eventually going to happen is the pads are going to be performed. All that movement that I just created from pad to pad, or point to point rather, is going to be remembered as a pulsing effect. And that's why it said initialize to 8/8 loop. Each one of these points is like an eighth note. Because we're modulating both of these X and Y targets plus the balance between the three oscillators. Now, just because you use the vector envelope doesn't mean you can't use the router as well. So let me go ahead and turn that amplitude modulation back on. I'll pull down the amount just a little bit, and I'll put this back on sawtooth. There's not enough variation at the end. Let's try doing some different things at the end here. So let's solo out the bass line. Let's see what this sounds like. So we get some more variation on the tone using both the main routers and the vector envelope. So that's modulation in a nutshell in the ES2. I know it's a lot crammed into one 20 or 30-minute video. If I went through every single modulation target and every single source, it would take me hours and hours to show you everything. Really, the best thing you can do is just go through and play around with it and experiment with getting different tones. And at the end of the day, it's all about trusting your ear and using your ear to get the tone that you want. Here, I just want sort of like a bass, a nice distorted but moving bass line. So I'm going to go ahead and turn my delay back on for this as well. I already have my reverb back in, and let's give this a listen. All right, so in the next video, we're going to move on to drum sampling, and we're going to create our own custom drum kit to create the beat for the song, and then we'll move on to really fleshing out and building the arrangement. So if you like this video, please leave it a thumbs up and subscribe to the channel to see more content like this. You can also check me out on social media at Facebook, Twitter, Instagram, and on Patreon. As always, thank you for the support and thanks for watching.